This video contains more examples on how to find equations from graphs and binomial powers. So the first thing we're going to do is we know that our equation is going to be a function. And we're going to identify where our x-intercepts are here. So we've got -2, -1, 2, and 5. I can tell that it is an even negative degree function because my ends are both finishing in the same direction. I'm going to put in my a value, which is my vertical stretch factor when it's compared to other members of the same family. And then I'm going to fill in my zeros. So x plus 2, x plus 1, x minus 2, and then x minus 5. I'm going to then use a point on the graph. In this case, I can identify that the the y-intercept, is right here. So x is 0, y is -3. It doesn't have to be the y-intercept. I could also use, looks like it goes through 3, 6 right here. That would be another point that I could read. I like to be able to substitute in 0, so that's what I'm going to do. I'm going to put in -3 in for f at x, leave my a. Got 0 plus 2, 0 plus 1, 0 minus 2, 0 minus 5. This means I get -3 equals 2 times 1 is 2. 2 times -2 is -4. -4 times -5 is +20. Then I'm going to divide both sides by the 20. And that gets me that a equals -3/20. I can then state my function including the a value. X plus 1, x minus 2, x minus 5. Let's take a look at another example. So first thing I'm going to do is state f at x. I'm going to put my a value in here, and then I'm going to identify my zeros. I've got x plus 3, x plus 1, and then x minus 1. In this one, I also have to check the multiplicities. So this one here is multiplicity 2 because it touches the graph but does not pass through. The second zero at -1 is multiplicity 1 because it goes straight through. And the last one, this one here, is multiplicity 3 because it goes through but doesn't behave like a line. So that would be degree 3. That makes sense. I know I have an even function because my ends are pointing up in the same direction, which is similar here. Except I've got a negative leading coefficient. My ends are going down. So that is a good thing to check with the multiplicities of the roots. This function happens to have the same y-intercept, 0, -3. And then I'm going to put in -3 for my f at x, 0 for all my x's on the right-hand side. And then I'm going to simplify. So I've got -3. And let's see, I've got 3 squared is 9 times 1 times -1. And then I can see that I've got -3 is equal to -9a. I'm going to divide both sides by the coefficient in front of the a, which leaves me with a equals 1/3. It is positive, which makes sense. The ends of my function are going up. And then I can state my function, including the a value, the roots, and their correct multiplicities. The other concept that we're going to explore in this video is another type of factoring. And this is one where we can actually factor out binomials that are in common. So normally in common factoring, we look between terms and we look for common factors that you can pull out. So the first thing I'm going to take a look at here is my regular numbers, 3 and 6. I know that I can divide both of those by 3, so I'm going to pull that out. Then I'm going to move on to the next part. x plus 1. And I see in this one I've got x plus 1 cubed. That means that I can take out x plus 1 squared from each of those terms without running into an issue, without not having enough in either of those. The last binomial that I'm going to look at, use purple, is x minus 4. I can see that there's an exponent 6 in the first one and an exponent 5 in the second one. So this means the most that I can take out of both of those would be x minus 4 to the exponent 5. And then this is going to allow me to write my remaining information in those terms after taking out those common factors. So 3 divided by 3 is 1. X plus 1 squared divided by x plus 1 squared is just 1. Those are the same thing. And x minus 4 to the 6 divided by x minus 4 to the 5 is just x minus 4, because I'm going to subtract the exponents. In my second term, I'm going to start with my number. So 6 divided by 3 is 2. And then I've got x plus 1 cubed divided by x plus 1 squared, which is going to leave me with x plus 1. And then x minus 4 to the 5 divided by x minus 4 to the 5 is just going to leave me with 1 there. So this is my remaining piece. And then I can rewrite here, and I can simplify my terms here. So I've got x minus 4, I've got 3x, and then I've got minus 4 plus 1 minus 3. And I can actually, I guess, factor out another 3 here. So then I would have 9 x plus 1 squared, x minus 4 to the 5 times x minus 1. Looks suspiciously like one of our other polynomial ones. The last example we will do in class.